Project 120 is light up the fan. We are going to use these two small circuits here, and we need a dim area, and the color LED flashes while the speaker makes noises. Now I'm going to hold down the press switch and be very careful not to touch the fan, but it's going to spin, and now it lights up. Well, the color LED continues to change colors. And you can see the individual LEDs more easily. You can see the light from the red, white, and green LEDs as the motor continues to spin. The reason why these circuits are independent but close together is because the motor sends out an electromagnetic pulse that could confuse the color LED, which has its own microcircuit, and therefore they can operate just right with the two smaller circuits. Project 121 is high power buzzer. Their circuit is similar to that in Project 116, but it is more complicated and has additional parts, including the fan and motor. We're going to turn on the slide switch, and the circuit will produce a buzzing sound. In this case, it's pretty high pitched, but it's very faint. And the motor is probably not going to spin. There's not enough power to rotate it. However, if you spin it manually, you might notice a difference in the tone that the buzzer produces. That's because I think the motor is producing an electromagnetic pulse, which will interfere with the current flowing through the rest of the circuit. Now I'm going to slowly adjust the RV lever. You can hear the sound becoming even more high pitched, and now we're going to decrease the sound. Kind of sounds like a siren when you slowly increase and decrease the pitch. The color LED also doesn't light up since there's not enough current to power it. Project 122 is called Buzz Fan. We use the same circuit, except we put the R3 resistor over the R5 resistor using a single snap wire, which may be hard to see, but that's what we did. And now we're going to turn on the slide switch. Now the pitch is even higher than in the previous project. And on some RV settings, the frequency of the sound is too high for human ears to pick up. And it's also possible that the fan might spin as well. And you might also would notice that the color LED flashes. I probably need fresher batteries in order for the motor to work on this project. Project 123, Photo Buzzer, requires us to repeat Projects 121 and 122, but we will add the photo transistor between these 2 points, point A and point B, here. Make sure that the positive side of the photo transistor is on the right, the plus sign, and then we will turn on the slide switch, and we're going to see how light on the photo transistor interferes with the operation of the buzzer while we simultaneously adjust the lever on the RV. When I cover the phototransistor, the sound becomes more high-pitched. Remove my hand, and the frequency decreases. Now I'm going to quickly put the R3 resistor over the R5 one and adjust the RV again. Covering the phototransistor makes the pitch higher. With the R3 resistor on, the pitch is too high for us to hear when the RV is at its highest setting. So covering the phototransistor does not really make a difference. Now the sound is at its lowest setting, without the phototransistor being covered. For project 124, Step Beeper, we're going to use the circuits from the previous 3 projects, but we replace the C2 capacitor with the C4 one. Make sure that the positive side of the capacitor is on the right. And now we're going to turn on the slide switch. And let's see what happens. This time, the fan does spin in short bursts, and also the color LED will flash, and even though it may be hard to hear due to the sound from the motor, the speaker will beep. And we can adjust the RV lever to increase the pitch. The C4 capacitor is increasing the rate at which the components work. Now it's all the way up. Now we can insert the R3 resistor over the R5 resistor, and now it spins much more frequently. I'm going to lower the RV to the lowest setting, and now the components work at lower intervals. Lastly, we're going to insert the phototransistor and see what that does. I'm just going to keep the RV on its highest setting, and will shining light interfere with its operation? Kind of hard to tell, but maybe it does increase the performance a little bit when you cover the phototransistor. Project 125 will also have us repeat projects 121 through 123, but we added the C4 capacitor across points A and B, and the positive side will be facing away from us in this case. We will turn on the slide switch and let's see what happens. I'm going to remove the R3 resistor. Now the sound is completely different. It may not be loud, but it sounds more like a bee or some other bug rather than being very high-pitched. I'm slowly adjusting the lever on the adjustable resistor. This time the color LED also lights up steadily. There's not enough current to spin the motor. Now I will put the R3 resistor over the R5 one, and now the sound is more high-pitched. Now I'm a little confused for 123 because putting the this requires you to put the phototransistor where you put the capacitor. Hopefully now you'll understand the concept of projects 121 through 125. Project 126 is Fiber Fun. This project requires us to build 2 separate circuits and we will connect them using the fiber optic cable. Using the white holder, we will connect one end of the cable to the color LED and then connect the black end to the phototransistor. And then we will turn on the slide switch and let's see what happens. The red LED flashes even though it's on a completely different circuit than where the slide switch and color LED are. That's because, like I mentioned in previous projects, the fiber optic cable is transferring the light through to the other circuit, and it's entering the phototransistor and it's powering the red LED. And in this particular case, the red LED will come on when there's light on the phototransistor and it will turn off when there's no light. And the color LED is basically commanding the red LED what to do. Project 127 is fiber fun backwards. We're going to use the same two circuits as in the previous project, but switch the locations of the phototransistor and R5 resistor. Now, the phototransistor is closer to me, and the positive end will still face away from me. You'll notice that the red LED is on even though the slide switch and color LED are off. Why is that? Well, we're going to turn on the slide switch, and the red LED now flashes while the color LED does so. But if you're able to look carefully, it's flashing in a different pattern. Now, the red LED is on whenever the color LED is off, and it's off whenever the color LED is on. That's because the phototransistor is working in the opposite principle. It is now increasing electrical resistance when there's light on it and decreasing it when there's none. Project 128 is more fiber fun. We will build these two following circuits and connect the fiber optic cable between the color LED in this circuit using the white holder and to the phototransistor on the second circuit using the black holder. We've included both the slide switch and the press switch, and we will turn on the slide switch and nothing happens. We will push the press switch now, and the light from the color LED is transmitted through the phototransistor through the fiber optic cable to the phototransistor powering the red LED. And at the same time, the speaker makes unusual noise. It's not very loud. Now, if we want to, we can switch the locations of the color LED and red LED. Or we could also use the white LED, but it may not be as bright. So I'm going to quickly do that. Now let's try it with the LEDs in the opposite places. The red LED does not flash, but because the color LED has a built-in microcircuit, it will, even though it's not being directly controlled by the fiber optic cable. $129 is other fiber fun. We use the same two circuits as in the previous project, but switch the locations of the R5 resistor and phototransistor. Positive end still stays away from me, and you'll see that the red LED is on. Push the press switch, and the red LED will be off whenever the color LED is on. Now, I think this is a mistake, but the manual says that the red LED will be on whenever the color LED is on. That's not correct. It's on whenever the color LED is off. So don't get confused by this if you have this kit and your manual says that.